Fine, guys. So let's start. Okay. So the other day, what did we discuss? So I think we have covered the quantiles and percentile concepts, right? And then we have discussed about the box plot and what is an outlier, what is an how to detect outlier, different ways to detect outlier, right? Just a recap. I hope you still remember these concepts. Fine. So now, today we are going to start something called as probability distributions. Okay, so this will be, yeah, so from here, it will be, you can call it as next level of statistics. Okay, because what we have studied uh, till last class very important, were like general concepts, okay, basic concepts. But statistics is all about, okay, statistics is all about distributions. Fine. So why we are studying all this, why we are saying mean, median, or box plot, etc., what all we have done. So ultimately we want to know, if given a data set, what type of distributions it is falling into. Okay, so and so forth. Fine. So for that, fundamentally you need to understand some basics about probability distributions. Okay, now let's try to understand from basics, guys. Fine. So now you can see my screen, right? Can someone confirm?
Yes.
Okay, fine. So now, yeah, so now initially if you see, what is, we need to understand few basic terms over here. Okay, so yeah, this will be like, you will be learning a lot of theory, you will be learning a lot of new concepts, new probability distributions. Okay, so be focused. Fine. So now let's start with a variable, right? So if we see about a variable, so I think you have already aware of variable in max. Let's say it's an algebraic, we see some algebra variable. So what is the example of algebra variable, guys? Let's say if we have x plus 10 equal to 100, right? So that means, what is the value of x, right? You know, x is a variable. That means it can take a certain value so that this equation gets satisfied, right? So that is a general algebraic value. But algebraic variable, okay, algebraic variable. Fine. Now coming to random variable in statistics, okay, coming to random variable in statistics. Fine. So it means that a set of possible values from a random experiment. Okay, so as I said, it will be a very new concept, guys, for you guys. So fine. So wherever you are having any difficulty to understand, so please feel free to stop and get your doubts clarified. Okay, so see, initially, what is a random variable? It is just a set of possible values from a random experiment. Fine. So you do any some random experiment, and that experiment should give some outputs. And what all the possible values that are possible from that experiment, all those are called as random variable. Okay. Now, for example, if you see a dice roll, okay, you will have a dice, right? So on that dice, uh, you can have what? How many numbers will be there? From 1 to 6 you have. Agree? 1, 2, like that you can have 6 numbers on the dice roll. So now if rolling a dice is a random experiment, okay, rolling a dice is a random experiment, then the set of these possible values, okay, 1, 2, 3, 4, 5, 6, fine. All these values are random variables, okay, because anything you can get. Okay, for example, if you're tossing a coin, okay, if you're tossing a coin, fine. So then tossing a coin is a random experiment. So what are the possible outcome, guys? If you toss a coin, heads or tails? Agree? Heads or tails? Fine. So similarly, for example, if in a school, okay, school GDP, or what do we say, school percentage, okay, school score. Fine. If that is a random experiment, okay, if that is a random experiment, then what? What are the possible outcomes? So usually the school GDP will be from 1 to 10. Okay. So from 1 to 10, you can get any score. Agree? So one person might get 9.8, 7.65. Fine. So there are like so many possible outcomes, but a list of all these outcomes, a list of all these possible outcomes from this random experiment are called as random variable. Okay. So random variable is simple. It is just set of all possible values that you can expect from a random experiment. Agree? So apart from this, you can think of any set of random experiments, right? For example, you are writing an exam. Agree? So what are the possible outcomes? Pass or fail. Fine. You are going for your interview. Select or not select. Agree? So those are all the possible values. Okay. And all those are called as set of all those are called as random variable. Fine. So now after that, now let's try to understand now what is a probability distribution. Okay, guys. Now what is a probability distribution? This is set of all possible outcomes of a random variable along with their corresponding probability values. Okay, let me read it again. See, probability distribution is nothing but list of all possible outcomes of a random variable. Same thing. What we studied here, set of possible values in a random experiment, same thing. But only thing addition is along with their corresponding probability values. Okay. In probability distribution, you'll also have their each random variable, its corresponding probability values also. Okay. Are you getting this? Did you understand like what is random variable and also what is probability distribution? Fine. So this is random variable is all the possible values. Okay. But each possible value will also have some probability, right? For example, if I if I toss a coin, right? What are the possible values? Heads and tails. Agree? Probable possible values are heads and tails. But here heads will also have some probability. Tails will also have some probability. So if you show the possible outcomes, okay, and also the probability values, fine. So then you can have probability distribution. Okay. The word itself is saying what is the distribution of the probability. Fine. Whose probability? Outcomes probability. Whose outcomes? Random experiment outcomes. Fine. So you will have a random experiment that will have some outcomes. Fine. So let's say some three or four outcomes. Each outcome there will be some probability. Fine. So outcome plus probability. This will give you the probability distribution. Fine. Is the definition clear, guys? Let me know.
Yes, sir.
Okay. So fine. Now we'll try to understand more about the probability distribution. So now you understood what probability distribution is. Simple. You will have it is just a probability distributions of all the possible outcomes. So we'll try to understand. For example, if you're having a coin, if you're tossing a coin, okay, if you're tossing a coin, so now what it will be? So coin toss. What is the possible outcome, guys? It's tails. That's it. Now what are the probability? What are the probability? 1 by 2, 1 by 2. Fine. How? Because what is the maximum value of probability? 1. I hope you know this, right? Any probability, any scenario you take, the maximum value of a probability is 1. And now what are the possible outcomes? 2. Two possible outcomes. So each one will have 1 by 2. Okay? 1 by 2, 1 by 2. So total you will have 1. Fine. So total number of probabilities and how many times H is occurring only once. One H is occurring only once. There are two possible outcomes. 2. Tails is occurring only once. There are two possible outcomes. 2. Fine. So this table, you can call it as a probability distribution table. Because how? Because you are having a random experiment which is tossing a coin. Possible outcomes, heads and tails. There corresponding probability values. Okay, probability values. So this whole thing you can call it as a probability distribution. Okay, fine. So similarly, you can also, for example, if you want to go for a tossing a sorry, rolling a dice. Okay, so for example, if you're rolling a dice, okay, so let me just a second, guys. Take, okay, so now you are rolling a dice. So dice roll. Okay, now what are the possible outcomes, guys, for a rolling a dice? 1, 2, 3, 4, 5, 6. Agree? And then what are the probabilities, guys?
1
Probabilities
by
is
6.
1 by 6, 1 by
1 by
6,
6.
1 by 6. Okay, same thing, 1 by 6. Fine. So you have the random experiment, you have the outcomes, possible outcomes. This you can call it as a random variable. Set of these possible outcomes is a random variable. And these are the probabilities, each individual probabilities. And the whole thing you can call it as a probability distribution, because you are also showing the distribution of the probability. What is it? How the probability is distributed among all possible outcomes. That is the exact value. Because the probability is one. The overall probability of any event should be one. The sum of all the possible outcomes probability. But how this one is distributed? Find how this one is distributed. That also you want to see. Okay. So here it is distributed equally. Fine. For example, in some other case, you might have 1 by 6, 3 by 6 in some other case. Okay. For example, let's say you are having a tossing a coin. So usually what are the heads and tails? Fine. So here it will be 1 by 2, 1 by 2. If it is a fair coin. Fine. So if it is a biased coin, that means if, intentionally you have manufactured this coin so that there will be more weight on the tail side. Okay, on tail side you have put the more weight in the metal. So if you toss a coin, it will always show heads, because tail side there will be more gravity, so tail side it will fall to the face of the earth, and on the upper side you can see the heads. Fine. So in that case the probability will not be same. Fine. The hits probability will be might be a bit more. Let's say it is 3 by 4, and tails will be only less, 1 by 4. Fine. So now if you understand here, the random experiment is same. Possible outcomes are same. This is not going to change. But the probability distributions are changing, right? So here, if it's a fair coin, if it is a fair coin, it is 1 by 2, 1 by 2. This is the probability distributed. Fine. Why? The overall probability is still 1. Fine. But the 1 is divided how? 1 is distributed in which manner? 1 by 2, 1 by 2. So that is the probability distribution. How the probability is distributed. Here also the probability is still same. It is not going to change. It's still 1. Fine. But how that is distributed? It is distributed in this manner. 3 by 4, 1 by 4. Agree? So this is a probability distribution of a coin. Fine. Similarly, you can see the probability distribution of what? A dice. See, probability is distributed in equal way. Agree? So now similarly, for example, if you have if you're rolling two dice, guys, rolling two dice, okay, and you want to see the probability distribution of sum some of these dices. Fine, some of these dices. So how it will be, guys, if I quickly draw. Okay, so if I quickly draw, so how it will be? So first dice, second dice, right? So what are the possible outcomes of first dice? First dice, 1, 2, 3, 4, 5, 6. Agree? What are the possible outcomes of second dice, guys? 1, 2, 3, 4, 5, 6. Agree? Now can you quickly tell me the sum, guys? Sum. 2, 3, 4, 5, 6, 7. Agree? Next, similarly, 3, 4, 5, 6, 7, 9. Sorry, 8. Agree? 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, 7, 8, 9, 10, 11, 12. Okay, fine. So these are all the possible outcomes. Some guys, you understanding some? That means if I roll dice, first dice, if I get one, if another dice, second dice, if I roll, okay, this is first dice, okay, this is second dice, okay. So if I roll another dice, if I'm getting also on the second dice also, if I'm getting one, so what is the sum, guys? Two, like that, okay. So now, what is the maximum value you can expect when we are rolling two dices?
12.
12, right? So maximum, you on one dice you can get 6, and another dice you can get 6. So maximum value is 12, fine. And the least value is 2, fine. So no matter what you do, you cannot get a value less than 2 and greater than 12, fine. So but now, now what is a random experiment? Or random experiment is rolling a dice. What are the possible outcomes? These are all the possible outcomes of the sum. We are seeing the possible outcomes of a sum of two dice. Fine. So what are these? What is the sum? These are all the sum. How many are there? 36. Fine. 6, 6. 36. Fine. So total possible outcomes, how many, guys? So what is the what will the probability of each value? Hmm? What will the probability of each outcome, guys?
1/36.
Correct. So it will be 1 by 36. Fine. So I can simply write like sum equal to 2, 3, 4, 5 till 12, and then each probability will be, actually each probability will be 1 by 36. That is fine. But now if you see, there are some repetitions. Agree? So if you see over here, 2 is repeated only once, 12 is repeated only once. But if you say 3, 3 is repeated 2 times. Agree? 4 is repeated 3 times. Agree? 5, 6, 7. Similarly, 8, 9, 10, 11. Fine. So except 2 and 12, everything is repeated. Fine. So now what is the probability of 2, guys? 1 by 36. Okay. Probability of 2 is 1 by 36, and probability of 12 is also 1 by 36. Agree? But now what is the probability of 3? Hmm?
1/18.
2 by
Correct.
2
Yeah,
by 3.
Srisha, you are correct. You said 1 by 18, but always you should keep the denominator same. You should not do the cancellation. But you said correct. But usually in probabilities, right, always try to keep the denominator same. So it will be 2 by 36. Agree? Simple case. Total there are 36 possible outcomes. In that, how many times 3 is repeating? 2 times. That's it. Similarly, it will be same for 11 also. For 11 also, it will be 2 by 36. Okay. For 4,
3/36.
correct. It will be 3 by 36. Fine. And same thing will be for 4 and 10. Fine. So it will be like that. For 3 and 11 will be same. For 4 and 10, because these are all repeating 3 times, and 5 and 9 is repeating 4 times. Okay. 6 is repeating only 6 and 7, I think. Yeah, 6 and 7 are repeating 5 times. Agree? So these are its possible, these are its probabilities. Fine. So it will be 1 by 36, 2 by 3 by 36, 4 by 36, like that. Fine. So now this complete thing is also called as probability distribution. Getting guys? You understood? Probability distribution of sum of two dices, right? So now see, now if you go back, that's fine. So when you are rolling a dice, when you are rolling a one dice, okay, when you roll a one dice, you got six possible outcomes. Fine. So one dice, six possible outcomes. Agree? Two dice, how many possible outcomes you got get for the sum? If you see 36. Agree? Now the point here is, if I have, let's say, 10 dice, okay, if I have, let's say, 10 dice, can you see how many possible outcomes we have?
6 power 10.
Hmm?
2 power 10.
Okay, 2 power 10. Okay, so it's extremely large, but still you can count. Okay, but what if the number of outcomes increased? Let's say 10 dice, it will be more. The possible outcomes will be more, right? So what is the possible outcomes? It will be more, but still, let's say if you count, what is the case if you have 100 dice? Very difficult, but even that is fine. Let's say you have patience, you are counting. But now if you see the case, this is still fine, but what if the output is continuous? Now we will be stuck here, we are caught here. Means what? Till now, what all example you are seeing, right? Heads or tails, 1 2 3 4 5 6, all these values are what, guys? These are discrete. These are discrete. Okay, so just switch back to our initial data concepts, right? So where I have told you, you will have two types of data. So I'll just give you a recap. So data is divided into two types broadly, right? One is categorical, right? One is numerical, right? In numerical, you have discrete, fine, and another thing is continuous. Okay, now we are focusing in this part. Okay, keep in mind. So we are focusing over this part. So what all the values what we are getting over here, right? So those are countable values, right? Those are countable countable values. The heads and tails, or 1 2 3 4 5 6, right? So at least you can count the numbers, right? So those are discrete values. Agree? Even if you roll 10 dice also, each dice will have only six values, 1 2 3 4 5 6. Those are still countable, so discrete values. But what if the output is continuous? Getting? What if the output is continuous? That means what? Same. If at all your score is 10, fine. So now see, guys, now try to understand. Now school score. School score is my random experiment. Random experiment. Agree? Now in random experiment, after that, what we want? We want the random variable, right? This is random experiment. Now random variable is what? Possible outcomes. That means what? Random experiment score should be between from 1 to 10. Okay, random experiment score is usually 1 to 10 is percentage. Now what are the random variable? Random variable is what? Set of possible values. Simply set of possible values from this random experiment. Now what are the possible values, guys? From 1 to 10?
1 to 10. 1 to 10.
Mhm.
Between 1 to 10.
Little loudly, Sirisha, you're saying from 1 to 10, what are the possible outcomes? They are infinite. Agree? You can get 7.6. Your friend might get 7.67. Another friend might get 7.666, etc. So like that, from 1 to 10, there are infinite values. Agree? So the random variable is infinite. Fine. So now what is the probability distribution? Now for the probability distribution, you need to calculate the probability of each and every value. Fine. So you need to calculate the probability of each and every value. Fine. And that is not that easy. Agree? Because you cannot find out the probability of infinite values. Agree? You cannot find out the value probability of infinite values. Fine. So there is a trick. Okay, we will discuss shortly. Okay, we'll discuss shortly. But here there is an important point which I will discuss. I'll also again revisit that. See here, guys. Actually, if you try to understand this, if you are rolling a dice, you got possible outcomes as 6. Fine. And what is the probability of each and every output? 1 by what is the probability of 1? 1 is repeating one time by total outcome 6. Probability of 2 is what? 2 is repeating 2 times. Total outcomes are 6, like that. Sorry, 2 is repeating one time. Sorry, 2 is also repeating one time. Total outcomes are 6. Similarly, 3 is repeating one time. Total outcomes are 6. Like that, every probability, every outcome probability is 1 by 6. Agree? Similarly, now if you come over here, what are the possible outcomes, guys? 6 is what? Total possible outcomes over here. Similarly, if I come over here, what is this? What are the possible outcome, guys?
1 by 10.
No. This 10 is just range, Sirisha. In between 1 to 10, what all possible outcomes are possible? Those, that is a random variable, right? Random variable is what? Possible values, all possible values. So if you roll a dice, there are only 6 possible values you can get, either 1, 2, 3, 4, 5, 6. Now, this is just a range. Okay, this is just a range, maximum and minimum value of the score in a school. But what all possible values you can get from this range?
Infinity.
Fine. So it's infinite. Agree? So infinite. So the random variable is infinite. Agree? Are you guys getting that? Why it is infinite? It is very important to understand why it is important. Why it is infinite. See, ఈ
Yeah.
1 to 10 మధ్యలో మనకి ఎన్ని వాల్యూస్ పాసిబుల్ అయితే, because this is continuous value, right? It is not a discrete. See, when you are rolling a dice, you will get only 1. You cannot get 1.5. Agree? You cannot get
Yes.
3.4. Dice roll చేస్తే మనకు 1, 2, 3, it's fixed values, discrete values, countable. Fine. But score, next school score unte you can get 9.5. 9.5 is also possible. 9.45 is also possible. Agree? 9.445 is also possible. Like that, between any two numbers you have infinite numbers. Agree? So like that, from 1 to 10, how many values are possible, guys?
Yes.
Infinite values are possible. Fine. So now if you want to calculate the probability of each and every value, fine, each and every value. So for example, let's say if you want to calculate this 9.5, fine. So 9.5 probability I want to calculate. Fine. What is the probability? How many times 9.5 is repeating by overall probability values. Okay, overall values. Fine. Here if you see, what is the probability of 2? How you got what is the probability of 1 here? How many times 1 is repeating? Only once. Total possible outcomes are 6. Fine. For 2, how many times 2 is repeating? Once. Total possible outcomes are 6. Fine. So now if you see, how many times 9.5 is repeating? Once. By total possible outcomes are how many? Correct. Infinity. Fine. So what will be what will be this, guys? Something by infinity will be very close to
0.
correct. Okay. So if you see any value you take, the probability will be close to 0. Okay. The probability will be close to 0 in a continuous variable. Getting? Why? Because the possible outcomes are infinite. Agree? You can take any value is possible. Getting? Because the range is, the possible outcomes are infinite, and infinite, if you're having it in the denominator, any value you divide by infinite, the value will be close to 0. Agree? So, but how to handle this, we are going to see. Don't worry. How to handle this, how to draw graphs for this, that is also we are going to see. Okay, but just let me know. So here, what I'm concluding is, now the point we need to understand here is, since we understood random variable probability distribution, now we actually have, okay, we have two types of probability distributions, guys. Okay, you have two types of probability distributions. Okay, so probability distributions is for, one will be for the discrete values, okay, one will be for the continuous value. Okay, discrete random variable, continuous random variable, you need to call this. Fine. So the random variable, whatever you are getting based upon the experiment, you will understand whether that is a discrete value or continuous value. Fine. So based upon the experiment, obviously if the values are discrete, if the values are countable, fine. So for example, how many students are present in a class, if someone asks you, that is a random experiment, obviously there will fix a number like 4 point, it cannot be 4.5 number of count of the students, so it could be like 40, 80, some fixed number. Agree? But now, what is the salary of a fresher? So if you see the salary of a fresher, so even if the range is starting salary might be from 20,000 to maximum salary is 80,000, but in between this 20,000 to 80,000 there are infinite possible values. Fine, infinite possible values. So if you consider the decimals also, like 30,454.32, so like that there are infinite possible values. Fine. So that comes under a continuous random variable. Fine. So broadly it is divided into two types. One is discrete probability distributions, one is a continuous probability distributions. Okay guys, are we good till this point? Please let me know anywhere you difficulty to understand. This is still basics. We'll understand like in detail like what is discrete, how to understand, how to draw, what is continuous, everything. But basic level, did you get an idea what is probability distribution and what is a discrete random variable probability distribution, or what is continuous random variable probability distribution? Let me know. Okay, fine. So I'll take that as yes. Okay, cool. So now we'll see there at a high level. So what all distribution? So you are going to study so many distributions, right? So any distribution you take in statistics case, okay, that will come under this probability distribution concept, and it should fall somewhere in between this discrete or continuous. Okay, so if you see some famous examples, okay, if you see some famous examples, right? Okay, so some top types of probability distribution machine learning. So if you will have uniform distribution, agree, binomial distribution, Bernoulli distribution, Poisson distribution, normal distribution, very important distribution, t-test distribution, exponential distribution, lots of distributions. Apart from this, there are like lots and lots of distributions. Okay, these are some common famous distributions. Fine. So, and in this, if you see, as I said, there will be discrete and also continuous, guys. Fine. So discrete distribution have finite number of different possible outcomes. Can you see this? This is having, discrete is having finite number of possible outcomes from a random experiment. What are the different types from above, whatever Bernoulli, whatever you're seeing? So Bernoulli, binomial, uniform, Poisson. Fine. So all this comes under discrete. The moment you hear discrete, right? So you should think that in this random experiment or in this distribution, when there are fixed number of or countable number of values are available. Okay, but if you see the continuous, okay, if you see the continuous, in continuous distribution function, you may have infinite many consecutive possible values. Agree? You have infinite number of values. Normal distribution, chi-square distribution, exponential, logistic, student tree, t distribution, etc. Okay, fine. So these are the different types of distribution. Now going ahead, let's see why are probability distribution so important, guys. Let's try to understand that. Okay, so we are trying to give so much time, fine, but let's try to understand why probability distributions are important. Okay, see, there are two things, two important things. Okay, first of all, it gives idea about the shape and distribution of the data. Okay, if you understand the probability, if you understand the distribution, obviously you can visualize the shape. Okay, so what is a graph, guys? Graph is simply just we are plotting the distributions. Fine, you're just plotting the distributions. Fine. For example, if you see over here, so the random experiments heads and tails. Okay, so now over here on the x-axis you will have possible outcomes. Okay, on the y-axis, let's say you are having the probabilities. Fine. So if the probability over here is, here it is 0, here it is 0.5. Okay, maximum probability is 1. Fine. So if you have heads, tails, if it's a fair coin, what is the probability? 0.5. What is the probability tails? 0.5. Fine. You can draw a bar graph, for example. Fine. But if it's a biased coin, okay, the probability of tails might be higher. Fine, tails might be higher. So you can get a graph from the distributions directly. Agree? So that's why it is important for us to understand the probability distribution. That's right. But second thing is extremely important. If our shape follows a famous distributions, we already know many details about the data. This is important, guys. What does this mean is, see, out when we are among these distributions, right? You can have, logically speaking, you can have thousands of distributions. Agree? That means what? What is a distribution? In simple words, it is some shape, right? So this could be one distribution. This could be some distribution. This could be some distribution. Okay, this could be some distribution. This could be some distribution. Right? So all this could be different distributions. Agree? But we cannot study all of this. There should be some limit. Agree? Now the importance of studying probability distribution is, okay, what scientists have done, they have studied some famous distributions. Why they are famous? Because they are mostly available in everyday life. Okay, in everyday life. Fine. So you can observe some famous distributions. Okay, for example, normal distribution. As I said, normal distribution is very natural. Agree? That means what? Initially it will be low, and at one particular level it will have a maximum values, and again it will start going down. Okay, that means what? As I said, the energy, if you take age, okay, if you take age, okay, and if you take y-axis as energy, okay, so usually what is the age? If you take age, just a simple example, if I take 0 to 20, I'm taking the age, and if I say 20 to, okay, 30, and 30 to 50. Okay, so usually the energy will be, okay, so 0 to 20. Fine, so it might be slowly increasing. Okay, so in the youth you might be maximum more energetic, and after that it will be decreasing. Okay, so like that you can have tens of examples where the day-to-day life random experiments, okay, follow a normal distribution. Okay, that's why they have invented this distribution. Similarly, you will have something t distribution, some will be exponential, Poisson, uniform, binomial, Bernoulli, etc. Okay, these are some of the famous distributions, guys. Okay, now the important point here is, let's say if you are trying to study a data. Okay, let's say someone has given you some data. Okay, and you are trying to plot this and trying to understand. Fine. So one thing is, you can try to get a shape and distribution of the data. That's fine. But the important point is, if at all your shape follows a famous distribution, you already know so much of the data. That means what? So you are having normal distribution. So when you are having a particular name, normal distribution, that means what? The research is already done on this. Fine. So we and the scientists know lots and lots of details about this distribution. Fine. So that's why they have given a specific name called as normal distribution, and they already know what are the parameters, how does it behave, what is its mean, what is its median, standard deviation, whether it is skewed or not, etc. They know lots and details about this distribution. Fine. So now when you are studying, so when you are focusing on new data, find some data, and if at all you feel after plotting, if at all you feel this is similar to a normal distribution. Okay, so if you decide that this is similar to a normal distribution, then obviously you can use all the properties of normal distribution. Agree? You don't need to again invent it from scratch. you already have its reference distribution available out there. Okay, so if our distribution also normal distribution, so you can use all the, you can assume few things straight away, what all normal distribution should follow. So you can agree directly, you can take all the its principles, rules, and apply to your distribution. Your work is already half done. Agree, guys? Are you getting? Fine. So that is the importance. Fine. So because if your distribution is already resembling, okay, if it is already matching, let's say if it is matching with Poisson distribution, fine. So you already have few details, few points about Poisson distribution. These are the rules, these are the principles. Fine. These are assumptions. So already your work is already half done. Fine. So that's why it is important to study the probability distribution. Fine. So if at all you are not doing this, again you need to start it from scratch. Okay, this is normal distribution. You need to again try to build everything on your own. But why to do that? Because you already have certain work done. So why not go and simply use that? Fine. It's just like imports, right? So you are doing in Max, right? So I think you in Python you have imported something called import random, right? And you are using random principles, random rules, random functions, what all. You are not writing random again, right? Similarly, same thing. If you have a distribution, if you have something already built based upon that, fine. You directly use all those. You don't need to invent it again. Okay, fine. So after that, let's try to understand what is a, or what are the parameters. Okay, so now parameters in probability are numerical values that determine the shape, location, scale, and distribution. Okay, so we'll see different probability distributions have different set of parameters. Fine, we'll see this when we are seeing the different probability distributions. Okay, but now let's try to understand what is a probability distribution function. Okay, what is a probability distribution function? Okay, so now see guys, just going a step back, here we faced a problem. What was the problem? If you're what is our final goal, guys? Our goal is to come up with probability. Our goal is to come up with the probability of each outcome, of each outcome. Okay, so what are, for all the possible outcomes, we want to show the possible each possible outcome ka probability. Okay, so if it is a dice, 1 by 6. If it is heads and coin, tossing a coin, 1 by 2. Fine. So that is fine. But here we understood that if the count is increasing, okay, or if it is becoming continuous, fine, it is difficult for us to directly tell the probability. So what will be the next solution? Max will be the next solution. Anywhere, if you are facing any situation, and if there is some pattern, obviously max will be the solution. So here, can we have some mathematical function? Fine. Can we have some mathematical function? Fine. So that which can give us the probability. Okay. Which can give us the probabilities of the random variable. Okay. Which can give us the probabilities of the random variable. Agree? So now let's see. That means what, guys? It's a simple mathematical function. For example, if you are having y equal to f of x. Okay. Now what is f of x? F of x is a, let's say it is a probability function. Probability function. So that means what, if you are tossing a coin, okay, tossing a coin heads and tails, okay, it will tell you now this f of x is a random function, and this value is going to be, and y, which is equal to f of x, is a probability which will be equal to 1 by 2 if x belongs to what? X belongs to heads or tails. Okay, heads or tails, and 0 otherwise. For all otherwise means there will be no other possible values, but still we write as a mathematical function. If it is heads or, if our x value, that means our random variable value is a heads or tails, then the probability will be 1 by 2, otherwise 0. Getting, guys? So with a function you can simply understand. Similarly, okay, similarly in this example, okay, in this example, if you see, you are having, okay, I will try to write here only. Okay, so here what will be the y equal to f of x, right? F of x will be, this is a probability. This will be what? 1 by 6, sorry, 1 by 36. Fine. When x equal to, when x equal to what? 2 comma 12. Getting guys? When 2 comma 12, our probability is 1 by 36. Fine. I'm writing a mathematical function. Okay. And now my probability could be 2 by 36. Okay. My probability can be 2 by 36. When my x belongs to 3 comma 11. Getting guys? Are you able to understand? Let me know. No?
Yes, sir.
Yes, right? Okay. So it's simple. The same thing I'm just putting in a equation. Okay. Because you can generalize what happens when you use a mathematical function. What is the importance of any function? Fine. So you can use that function for all the possible outcomes. Fine. It is sort of generalizing. Fine. You don't need to individually write for each possible outcome. You can just write a function. Fine. So that if at all, if the sum is 3, if sum is 3, fine. So you will have the probability is 2 by 36. Directly by looking at this chart, you can tell the what is the probability. Fine. So that is a way how you can come up with a probability function. Okay. Probability function is a mathematical function, okay, which will give you the probabilities. That is simple example. But now what about the continuous variable? Or what about some other discrete variables? Okay. Now we'll try to understand that. Okay. So now what is a probability distribution function? Okay, we'll try to understand this. Okay, I hope you are on track, guys. Okay, so yeah, I understand that there are like a lot of new topics. Okay, I strongly suggest you to go through the class again. Okay, but now we did not discuss so many things. We just understood what is random variable. We understood probability distribution. That's it. And in that we have seen that discrete and continuous random variable you can have. So if you're having two types of variables, obviously you will have two types of distributions. Okay, you can have discrete probability distribution. You can have continuous probability distribution. That's it. Fine, simple concepts. And after that, we have seen some basic, normal, famous probability distributions. Okay, and in that, what are discrete, what are continuous. Fine, and then mainly we try to understand what is a probability distribution, why it is so important. Because if at all it is already following a famous distributions, we can directly use all those properties. Okay, that's fine. So I hope we are good till this point. Fine. So next thing is, what is a probability distribution function? Okay, so now here, fine. So probability, oh, actually this should be, okay, so just give me a second, guys. Probability, sorry, fine. Fine. So now if you see what is probability distribution function, fine, this is a mathematical function that describes the probability of obtaining different values of a random variable in a particular probability distribution. Okay, simple, nothing confusing, same thing which I've just expressed. If you are having y equal to f of x, okay, this is a function that describes a probability. Okay, this will give you the probability obtaining from different values of random variable in a particular probability distribution. Okay, so you're doing random variable that will have some outcomes, and each outcome will have some probability. For that, you can denote by a simple mathematical function. That's it. That is probability distribution function. Okay, here you are using function. Fine, so that our job will be much more easier. Now the actual cinema starts. So this probability distribution function is mainly divided into two types. Okay, one is same thing. One is for the discrete variable. One is for the continuous variable, guys. Okay, same thing. Whatever we have studied, right? So one is for the discrete, fine. One is for the continuous. Okay, so these two are studied separately. Okay, so for discrete variable, the probability function which you are going to study, it's called, focus guys, probability mass function. Okay, so this you need to remember. So these are very important concepts. Fine. So the terminology also you should focus and remember. Fine. For a discrete variable, we have seen, right? For a discrete variable, okay, if you are studying for a discrete variable, the probability distribution function is called probability mass function. Okay, probability mass function. Fine. For continuous variable, it's called probability density function. Okay, it's called probability density function. Okay, so here its probability mass function is denoted by PMF, and probability density function is denoted by PDF. Okay, usually this probability distribution function you have, right? So this is also PDF. If you see, this is also PDF. Okay, but probability density function is also PDF. Fine. So usually you might get confused, so that's why I'm calling, I'm going to call probability density function as PDF. Okay, and probability mass function as PMF. Okay, probability mass function as PMF, probability density function as PDF. Okay, and using these two you can do something called as cumulative distribution function, which we are going to see, but that's fine. Okay, so this is the main thing which we are going to discuss, guys, over the next I think tomorrow, and if possible day after tomorrow also. Okay, but this is the actual thing you need to know in statistics. Main thing is probability distribution functions, and in that PMFs and PDFs, there will be only two concepts. Okay, if it is discrete, PMF, continuous, PDF. Okay, fine. So let's try to understand probability mass function. Okay, so coming to probability mass function. Okay, coming to probability mass function. Fine. So see, in probability and statistics, a probability mass function is a function that gives a probability that a discrete random variable is exactly equal to some value. Fine. So I'll explain. Simple, same concept we are studying again. Why it is probability mass function, guys? Why did it become mass function? Because the variable is discrete. Okay, see here. Mass function discrete. Okay, you remember density function continuous. Fine. So now this probability mass function or PMF. Okay, this function will give you what? This function will give you the probability of discrete random variable, which will be equal to some value. Okay, simple. Probability you are getting same thing, but here in this function is giving you. Fine. So earlier we have discussed, we have manually extracted, right? So if it's tails 1/2, dice 1/6, right? But here you are using a function, and that is called probability mass function, and this will give you, this will work for only discrete random variable. Agree? So are we good, guys? Till here, are we good, everybody? Any confusions, guys? Any doubts? Any confusions? Any clarity missings? Or are we going on track? Gone. Sleeping. Oh my God. Okay, fine. Lost track. Shall I stop here? Hey guys, are you there or not there? What guys? Sleeping morning. Okay, fine. I'm going to stop the class here. So tomorrow we'll discuss probability, mass, function, and the other concepts. Okay.